motorcycle oils. They're more expensive than regular car oils. But are they worth it? Is what's in this bottle chemically different than a regular car oil or diesel oil? Hi, I'm Lake, the motor oil geek, and back when I worked at Joe Gibbs Racing, we actually had a professional motocross team. And I can tell you that the oil we used in those engines made a big difference. Because motorcycle engines normally share the same oil with the clutch, the oil has to work good for both the clutch and the engine. Get that oil choice wrong and you might not finish the race. Ask me how I know. Unfortunately, Joe Gibbs Racing Motocross doesn't exist anymore, so I can't take you inside to show you the details about motor oil formulations for motorcycles. However, my friends here at Amsoil said we could come inside and visit their research lab to show you how and why motorcycle oils are formulated different than passenger car and even diesel oils. So this is my good buddy, Lynn Groom. You've been here for a long time, have you?
Yeah, it's been 15 plus years.
Right, and you've been in charge of power sports and racing oil, so this whole idea of motorcycle oil and how important it is to engine and clutch performance, you've lived this.
My entire career at Amsoil has been nothing but power sports and racing, as you said. So yes, I've been directly involved in the building of the products, the testing of the products, both personally and from a lab testing standpoint. So yeah, we love to test at Amsoil.
That's a good thing, because testing is where it's at. Without testing, you're just guessing.
Yep.
And guessing doesn't work very good. Again, ask me how I know, right?
Exactly.
Some things you think are gonna work really good don't work in real life.
Some of the best planned stuff we've done here ends up in a failure, and it causes us to learn, change it, move forward.
I can hear that right now, actually. You may be able to hear the background noises because there's testing going on all over, because this is your mechanical testing lab.
It is. This is a test facility that we put in, out of necessity, because this is where a lot of times we'll start with different formulary developments in this area. Power sports, it has a somewhat of a priority down here because our capabilities really lean towards the power sports in this facility, but also power sports sometimes lack specs, or the specs are just a minimum standard. So we've found that really getting in and doing some of the actual testing has really proven well worth our time.
Speaking of that testing, so JASO, clutch performance testing, that's one of the real key differences here between a passenger car oil or a diesel oil and really a motorcycle specific oil. A lot of times is the clutch performance, because a lot of times motorcycles, clutch oil is the same oil as the engine oil.
That's correct. That is a unique problem in and of itself. Fortunately, we use a split sump Honda where we can actually do crazy wild formularies and then start dialing it in. So get the frictional squared away right away and then really fully formulate for the shared sump bikes, which are now all you can get.
Right, because friction and wear are not two sides of the same coin.
Correct.
You can affect friction in one direction and affect wear the other direction. They're not always reduce friction, reduce wear, increase friction, increase wear. So you're probably thinking, how can friction and wear not be related? I get it, it's confusing. Fortunately, we did a video on ZDDP that explains how friction and wear are not always related. We'll leave a link for that video in the description box below. With motorcycle formulations, you get to be really specific, and then you've got these crazy air-cooled engines.
Right.
Then
you put it in a V-twin that has no liquid cooling, and we're gonna go really slow with it, and the temperatures are 300-400 degrees cylinder temps. I mean, it's wild.
And it's a V, and they're not sideways, it's like this, so you have one that has air and one that doesn't get much air.
Correct. Yeah, and we're gonna take a look at that. We actually have one fresh off test, and we can take a peek at it.
Let's go see that. You can see with your eyes the difference in deposits between the front and the back of that engine. It's crazy.
As we talked about earlier, it's not always going to be a win.
Yeah.
This is called testing.
Yes.
Anytime you get into development, anytime you get into doing something that isn't necessarily spec-based, you run that risk. But at the end of the day, it's worth the risk because you're building a better product for the machine. Yep. So application specific. So in this test, this is a Milwaukee 8. So this is Harley's latest engine.
Okay.
This test here is 250 hours, 15,000 miles. So longer than the OEM drain interval, right? We recommend, or we test longer than OEM drain intervals because we build in what we call reserve protection.
Yeah,
right, as you're very well aware.
Yeah.
So this is 250-hour test. Let's see, 30% of it is over 80% load.
Okay.
The rest of the test is fairly realistic to the real world.
Yeah.
But we add in that little bit of extreme
Yeah.
to drive the temps up.
Absolutely. You have to push the oil to find its breaking point.
Correct.
And if you don't find the breaking point, you don't learn, right? So
Right.
you say that's a fail, but really, when you see that deposit, you're like, oh, okay, we found the breaking point.
Correct.
So now what can we learn from that to be able to raise that breaking point and push it even further?
That's correct. And then what you also find, which is really cool, and this is what I really get into, is you found the location of that breaking point. Because if you look at these cylinder heads, you'll notice that the rear cylinder, the back of the rear cylinder, which has the least amount of air, it's got the most heat, it's got the most staining.
On the exhaust side.
Yeah, well, the exhaust side generally looks worse.
Yeah, exactly.
Yeah.
Even little things like these retainers. Like, I mean, the difference between the intake and the exhaust is just so apparent in the amount of deposits.
Yep.
That exhaust is just a whole lot hotter compared to that intake.
And if you look at the stems on the same exact valves,
oh yeah.
So if you take a look at a stem, you'll be able to see, see that staining right there?
Yep.
Sometimes these will actually stick in the guide.
Yes.
So they'll build up and the valve will get lazy.
Mm-hmm.
So when the engine is off and cold, the valve could be stuck. Then when it starts up, it's cold stuck, as you know. But we even look at these types of deposits on the valves.
Really important.
Very much so.
Again, these are these little differences between a motorcycle engine and a car engine is that these parts are different. The environment's different. You know, being air cooled just really taxes the engine in a completely different way.
Right. You're a slave to ambient temperature with a Harley.
Yes.
With any V-twin that's air cooled, not just Harley Davidson, but you're a slave to ambient temperature. The hotter it is outside, the hotter your sump temp's going to run.
Yeah.
Add Sturgis to the mix, 2 miles an hour, engine still idling. It gets hot really quickly.
Yeah, hot idle is not a good thing. Right?
Ever, not with air cooled.
No, absolutely, because you don't have that much air flowing around. Which again, look at the pistons. I mean, look at that undercrown of that rear cylinder compared to the front cylinder. I mean, that is just a massive difference.
Right. So these are areas that now what we do is we'll take a test like this, and then we'll work on this. Mm-hmm. We'll formulate. We'll change different pieces of the oil, as you know. You know exactly what we're going to do. Right? What are you thinking right now? You're thinking, okay, I do this, this, and this. That's guaranteed what he's thinking. I would do these 4 things. And you and I have mostly agreed over the years on a lot of the things that we were saying. Right?
Yes.
Some of the different trends in the industry.
Right.
He and I have always agreed on those things.
Well, that's the thing that, from my time when I was a driven, and obviously you guys do here, we had the same focus.
Correct.
Building a better product. And when you get into something like this, where there's not an API spec for motorcycle oil, it's really down to the manufacturer to go do the work and create something that exceeds, we'll call it...
the low standard.
Yes.
Yeah.
Because yes, you could just take a diesel oil and put it in that engine and run it. And even if it's got a wet clutch, the frictional characteristics of the diesel oil, because it doesn't have friction modifiers, and they are more shear stable, and we'll get to that and why that is different in a minute, it will function.
Sure, it'll work.
But is it ideal?
It is not.
Because there's a lot of things specific about these environments that a diesel oil doesn't address.
Sure, just the heat by itself, right? Your antioxidant dispersant detergent package changes from a diesel oil. Will it cover you 70% of the time? Sure. But what happens when you're slow walking your bike down the street in Sturgis? I always go back to that example because that is the worst thing you could do to a V-twin. And where do we collect them all once a summer? Sturgis.
Yeah.
And we're all going slow. It will not cover you there. That is the upper tier, and that's where we play at Amsoil, is that upper tier of what's the worst thing somebody could do to this? Yeah. That's where we work.
And a big key is how much oil is one of these engines versus that big diesel truck. Right. There are big Mack diesels out there and Cummins diesels that take gallons of oil.
Agreed.
And you're talking about quarts of oil.
4 quarts.
Yeah. So that oil to fuel ratio, the amount of heat that's going into every specific volume of that oil is much higher.
Sure.
So it's harder on the oil.
Your cycle time, right? You're talking cycle time. It's going to be cycled through that engine way more.
Right.
So it's doing a lot more work.
So it's a more taxing environment, which is why the chemistry has to be different. You kind of heard him say it a minute ago, and you follow this channel, you know my rule. Application always dictates chemistry. We say that all the time on the videos in this channel, and that's what you guys are doing here.
Yes, it's exactly what we do. Yep.
So
and we do it day in, day out, and as we see here, it's not always a win. Sometimes there's work to do. Sometimes we learn things.
So speaking of some other wins and losses in application chemistry, let's talk about those clutch discs. When we started off in the very beginning, that motorcycle oil, when it has that clutch, there are really two big things about a passenger car oil that really don't make it ideal for a wet clutch application. What are those two things?
When you start building a motorcycle oil, you start looking at passenger car, building blocks. And you're going to find right off the bat that today's fuel economy standards, the requirements for friction modification to make those standards do not play well with a wet clutch, because what does a friction modifier do? Makes it slippery.
Right.
What is a wet clutch not like? Slippery.
Right.
So you have to start there.
And they tend to shear the oil more too.
Correct. Yep.
And so in a passenger car application, it's pretty common to see oils shear out of grade sometimes as a way that people use to get that fuel economy requirement.
Exactly. Yeah, you get it to shear down. You don't want that to happen in a high heat V-twin or high RPM dirt bike.
No.
You don't want shear.
You want to maintain your viscosity.
Right. So you're working against basically everything that passenger car oil has become to build a proper dirt bike oil, V-twin oil, any type of motorcycle oil.
Yeah, so you're not just modifying a passenger car oil to make it work for a motorcycle. No. You're really building from the ground up to make it specific.
Right. You might use some of those building blocks, as somebody that's done this before, you might use some of those building blocks, but not in the same way. You'll take something that an extended drain interval does well, use it to your advantage in the base oil chemistry for a V-twin.
Yeah.
Totally different application of similar technologies. You see what I'm saying?
Absolutely. Back to like ZDP. So zinc is great at being an antioxidant and an anti-wear additive. It can also help modify your clutch friction.
That's correct.
Because ZDP typically increases friction, even though it decreases wear to a degree, right?
Yes,
so it's all that balancing act of what's my application, how do I adjust the tools, the chemistry to meet the needs of the application. So do you have some examples of some?
I do.
Some clutch stuff? Let's take a look at that.
So to talk clutches, we got to change platforms. So let's take a look at a dirt bike that we use to actually formulate some of our products.
All right, sounds good. All right, Lynn, so what we got here?
Well, we've got a win and a loss, since we're talking wins and losses. Well, we've got a failed clutch disc.
This looks familiar, by the way.
Yeah. Oh yeah, we've done bunches of those, and then we've got a winner.
That one looks nice.
It's fairly used up. It's not smeared, so that's kind of the key.
Right. Because it really is that transfer of material. When it overslips, that's where things go. Yeah, it gets that downward spiral, right?
Yep.
It gets hot, you get deposits, the oil breaks down, and everything just goes downhill. Next thing you know, the bike's not moving again.
Right. Or it's doing something that the rider doesn't like, and then you're hearing about it, and then we're back at the drawing board, trying to figure it out, because you know how that goes.
Well, especially with motorcycle racing, the clutch performance cannot be something conscious.
No.
It has to be a subconscious reaction. And when they feel and sense the clutch doing something weird, it breaks their concentration and things go bad.
Correct. You're 100% right. And we've done similar work on this, right? We worked with Factory Connection, which was a Honda team.
Right.
So we had the luxury, which you didn't, of the split sump.
Yes.
So we could really get crazy with some formularies.
Right.
And we learned a ton when we were working with them, because the feedback was the rider in the gate ready to go, right?
Yep.
Since bike's in second gear, third gear, depending on the rider.
Yeah.
Slight amount of throttle, let the clutch out just till the bike wants to move, then you're staring at the gate the whole time, and you do not want the bike to move.
Right.
The bike was moving, and then they had to chase it.
Yes.
So you see it moving.
Yeah.
You don't want that. So we started formulating around that, and we actually took an MA2 product, and we're going to get into that in a second, and we made it actually a little more slippery, turned it into an MA, and we made that lever more progressive.
Okay, let's talk about it, because JASO, the MA2 and the MA, that's something where people may be aware of it, maybe they're not aware of it. It can be confusing. So explain what that means.
It's extremely confusing. You see any motorcycle oil, anything with a wet clutch will have an MA2 or an MA rating on it.
Yep.
That speaks directly to the oil's frictional characteristics. You will not find a passenger car oil that makes those.
No.
So that's the ability of these clutches to grab on one another, and how slippery they are gets them a rating.
Yes.
MA being slipperier, if you will, than an MA2. MA2 is the most aggressive grab.
More grip.
Correct.
And that's the thing, each application is going to have its own needs. So
Yes.
a dirt bike could be different in terms of what it needs friction-wise than, say, an asphalt road bike.
Correct. Or even a V-twin, like a big heavy V-twin. They're heavy. There's a lot of rotating mass there. So the bike is not as sensitive to the dynamic friction index, the progressiveness of the lever. The motor itself will provide that because it's big and it's turning and it's heavy and it doesn't want to stop.
Right.
Dirt bike, not the case. You take all the rotating mass as you can out of this motor.
Right.
Because it makes it really fast.
Yeah.
Right?
You want it to rev up.
It makes it really quick. They rev instantly.
Yes.
Problem is, very, very sensitive to how progressive your lever is.
Right.
So you have to change. So you'll see our motorcycle oil is an MA2 for the V-twin,
Yep.
the metric bike stuff. The dirt bike oil is an MA. We
Got it.
changed one of the characteristics slightly through hundreds of hits on the dyno
Yeah.
with this bike
Yeah.
and me sitting on it
Figuring it out.
over and over again. Second gear gate start, burning up clutches, getting that formula where we want it, where the rider can just sit there and wait, and the gate drops and away they go. So that's a lot of time in that.
Application always dictates chemistry. You just heard it, right? You have different motorcycle oils for the different applications of motorcycles, because
That's correct.
they're not all the same.
No, they can't be. Not if you want to perform at the top of your game. You just can't.
And we're talking about motorcycle oils right now, but the reality is that's no different than all motor oils.
That's correct.
From a diesel oil to a passenger car oil to this or that, from racing oil
Yes.
to a street car oil. You're always changing little things
Yeah.
to meet the needs of the application, because they're not all generic.
No, you can't just apply one solution to everything or try and change it to mold it. You have to start from the ground sometimes and build up.
Right. Which is what you guys do here.
Great. That's what we have. You have no choice. If you want to do it the way we do it, that's what you do. You
Right.
just start breaking things and you go from there.
So, while we're here at the research lab, is there anything that you would like to show us that's maybe new and cool
Well, there might
that
be
you've
some
come up with?
Sure, there might be some stuff.
All
Let's take a look.
All right. Analyzing the oils that Suzuki provided to Joe Gibbs Racing Motocross is how Speed Diagnostics actually got started. Using another brand oil wasn't an option for the team, so it correlated the chemistry of the oil to clutch performance to help the team choose the right oil. In a sense, without motorcycle oil, there's no Motor Oil Geek. What is this, and why are there so many back there?
That is a two-stroke trimmer engine.
Okay, and why do you have 12 of them back there?
That's a dozen. Yeah, that's a dozen. We like to run a lot of them at a time. This is an excellent platform to test two-stroke oil.
You know, that makes sense, because this isn't the most highly engineered engine, is it?
It is not, and it is air-cooled. It is hot running. It is a nightmare to build an oil that will last for that engine.
Yeah, because it's bad environment and not really the best engine in the whole wide world. So it's a really good engine to test oil, to find it if you can break the chemistry.
That's correct. And you can break the engine, right? So we can break a pile of these and then graduate to something more expensive, right? You see all these high-tech pieces of equipment around here. If we start here, the nice thing is they're cheap. And they're crazy, crazy hard to build oil for. They're 500-degree spark plug temperatures, insanely hot cylinder temperatures. They love to deposit. They love to try and stick rings. So it's like a super big puzzle, and we love trying to figure out that puzzle.
Right, and you don't want to stick your rings. It's not nice to stick your rings.
No, we don't like that.
So what's the cycle you've got going back here? Because I see these things running back in there.
Yep, this is a 300-hour step cycle they're running that somewhat replicates what the trimmer would see in a lawn and landscape environment. So it runs idle, it runs mid, then it runs wide open for 300 hours, and it steps through real nicely so you get real good data. You can run 12 of them using the same air, the same weather. Everything is the same in the dyno, which we love to eliminate variability. So that allows us to do that.
You run a bunch of different candidates that way, and then you got really good data.
Correct. It's very, very repeatable. You can run several candidates, against us, competitors. Sometimes we just test against ourselves in certain situations, and then we like to, use it to help build other things such as snowmobile oils or two-stroke dirt bike oils.
Right, because just because it's a two-cycle, you can still find out what's the breaking point of the base oil or the antioxidant. You can learn a lot from one of these little things you can apply to anything.
Yeah, you can apply it everywhere. And it's just a matter of changing those levels to the appetite for the engine, right? Application specific, as we've been talking about.
Right. Application always dictates chemistry. That's why we're here at Amsoil. Lynn, thank you so much for letting us come in and hang out. This has been a ton of fun. Hope you enjoyed the video. Thanks for watching.